All right. So now we're ready to continue again. My other video, I had too many interruptions with announcements over the PA. So I just chopped off the ending and going to start here with part B where I chopped off the video. So it was just too many interruptions. So I wanted to make you have a cleaner video so you can understand what I'm talking about. All right, so we're on example number 2. We have our cycloid, that's our parametric equations with x and y, r being some radius value. Theta is actually our variable. And the question is, at what points is the tangent horizontal? Okay, and this is the derivative that we did in part A that we already did, and I have written it here in part B so we don't have to calculate that over again. So our derivative is sine divided by 1 minus cosine. So now we want to use that to figure out where do we have tangents that are horizontal. So if you look at your sheet at the bottom, in order to have tangents that are horizontal, that means dy dt has to equal 0, but dx dt cannot be 0. So we want 0 in the numerator, but we do not want 0 in the denominator. We want 0 divided by some number other than 0. All right, in order to get a horizontal tangent, we want this to equal 0. So dy dt means we want the sine to equal 0, but we want the dx dt, the 1 minus cosine, to not be 0 because we don't want to have 0 in the denominator. So when sine is 0, that's going to be on the unit circle. Think where the sine value has a 0 value on the unit circle. That's at 0, has a 0 value. That's going to be 0, pi, and 2 pi. Okay? So sine is 0 on the unit circle when the angle theta is 0, pi, and 2 pi. All right, and then over here, we don't want 1 minus cosine to equal 0. So let's solve and see what this would be. If I add cosine to the other side, that means we do not want cosine to be 1. So think about on the unit circle, where does the cosine have a value of 1? And that would be at 0 and 2 pi, which are actually the same place on the unit circle, 0 and 2 pi. Now, we don't want theta to be 0 and 2 pi. So over here, we want theta to be one of these 3 options. So right now, theta cannot be 0 or 2 pi. So that means theta is pi is one of our answers. Theta is pi. Now, I'm going to come back to these guys here in just a second, where theta is going to equal 0 on the top if it's 0 or 2 pi. It's also going to be 0 in the denominator if I have 0 and 2 pi. So for the numbers 0 and 2 pi, I'm getting the indeterminate form 0 over 0. So I'm going to come back and talk about that in just a minute. So for pi, the top is 0, but the bottom is not 0. So I have 0 divided by some number. So I know I have a horizontal tangent line at pi. So when theta is pi, now we just want to figure out what the points are. So in order to figure out my points, I just have to put pi into the equations here. So if we put pi into this equation, the sine of pi is 0, and then I'm putting in pi here, so I'm going to have pi times r. And then putting pi into this equation for y, the cosine of pi is -1, so this is going to be 1 minus -1, so that's going to be a 2, so that's going to give me 2r. So all I did was I took my answer, theta is pi, and I put it into my equations for x and y. I put theta is a pi, okay, and I calculated my answer. So this one gave me pi times r because the sine of pi is 0, and this one's going to give me 2 r's because the cosine of pi is -1, so 1 minus -1 becomes 1 plus 1, so that gave me 2r. So this is the point where theta is pi, where we have a horizontal tangent. So that's the answer for that one. Now, something happened though at 0 and 2 pi. At 0 and 2 pi, we end up getting the indeterminate form 0 over 0. That doesn't tell me anything. That's not a horizontal. I don't know what's happening there. So we have to investigate each one of these individually. So to do that, we're going to take the limit and let theta go to our first answer, 0, and we're going to use our derivative and see what our derivative equals. equals, okay? So right now we know at 0, I'm getting 0 for both of these. So I know putting a 0 in here, I've got 0 over 0. So this is an indeterminate form. The same thing is happening when theta goes to 2 pi for our derivative. It gives me 0 on the top. It can't be those numbers on the bottom because it also gives me 0 on the bottom. So for 2 pi, when I put 2 pi into my derivative, I'm getting 0 over 0 again. So I'm getting the indeterminate form for both of those answers, 0 and 2 pi, because they occur in both of the choices. So basically the test fails me. I don't know what's happening at 0 and 2 pi because I'm getting 0 over 0, which is an indeterminate form. So I need to take the limit and see if I can see what the limit's approaching. Because whenever we get 0 over 0, what are we allowed to use? We're allowed to use L'Hopital's rule. So the limit as theta goes to 0, I'm going to do L'Hopital's rule. So the derivative of sine is cosine. The derivative of 1 is 0, minus the derivative of cosine is negative sine, so that makes that a plus. All right. So what am I going to get here? I'm going to get, when I put theta as 0, this is going to give me cosine of 0 is 1. So this is going to give me 1 divided by sine of 0 is 0. So that means this approaches infinity because I have 1 divided by 0. Undefined, so it approaches infinity. And let's do the same thing down here for the 2 pi. I know when I put 2 pi in for both of these, I'm getting 0 on both of those. So I'm going to do L'Hopital's rule again. So as theta approaches 2 pi, so again, L'Hopital's rule is taking the derivative of the top, the derivative of the bottom, and then I'm putting 2 pi in here, all right? So the cosine at 2 pi is 1. The cosine, the sine at 2 pi is 0. 1 divided by 0 goes to infinity. Now, that's telling me that my derivative goes to infinity. The derivative is the slope of the tangent line. So if my tangent lines have a slope of infinity, that means these are vertical tangent lines. All right, and this is going to come into play when you see me do the next problem. So these are definitely not horizontal tangent lines because I didn't get an answer of 0. So if this had been turned upside down, I would have gotten 0 over 1, and these would have been horizontal tangent lines. All right, when I took the limit. So now let's do, so the only answer for this one is pi. All right, so now let's do the last question, the very last question, which is find where there are vertical tangent lines. Well, I think we've already got what our answers are here. Okay, so our derivative, dy dx, remember, was sine over 1 minus cosine. All right, so in order to have a vertical tangent line, I need my bottom, which is dx dt, to equal 0, and my numerator, dy dt, cannot equal 0. Okay, so 1 minus cosine, so it's just the reverse of the last problem, so I'm going to get the same answers. All right, sine cannot be 0. So here, cosine has to equal 1. So where does cosine equal 1? Cosine equals 1 when theta is 0 or 2 pi. Over here, I don't want the numerator to be 0 because that would be a horizontal tangent line. So I don't want the numerator to be 0. So sine cannot be 0. So what angle measure gives me sine 0? Well, that's 0, pi, and 2 pi. Now, so theta is either 0 and 2 pi, but it can't be over here 0 and 2 pi. So this tells me basically I have the indeterminate form, so my test fails me. So I have to do what I just did in the last problem again, do the limit and let theta go to 0 for my sine. And we already did this, so we're doing it again because it's the same problem. And then the limit as theta goes to 2 pi for the derivative. So if you remember what we did on this, when you put a 0 in here, this gives me 0 over 0. So I do L'Hopital's rule. So that'll be cosine over sine. So now this is going to equal 1 over 0, which is infinity. So that means we do have a vertical tangent line here. Same down here. When you put a 2 pi in here, you're going to get 0 over 0. So I'm going to do L'Hopital's rule. L'Hopital's rule is the derivative of the top divided by the derivative of the bottom. And then you try again. You put 2 pi in here. 2 pi, the cosine of 2 pi is 1. The sine of 2 pi is 0. 1 divided by 0 is undefined, so that goes to infinity, which means we have a vertical tangent line. So even though this says that dx has to equal 0, and it does at 0 and 2 pi, but dy dt cannot be 0, and that means it cannot equal 0, pi, and 2 pi, which counteracts these answers over here. That means my test pretty much fails me because these two guys are wiped out because of these two over here. So that gives me the indeterminate form. I end up with 0 over 0 is what I've got. So I have to do another investigation to figure out what's really happening at the values 0 and 2 pi, because I get 0 for both my numerator and my denominator. So you take your limit and you let theta go to 0 and then do L'Hopital's rule. So you can investigate to see what these answers are. All right, if these answers turned out to be zeros, then we'd have horizontal tangent lines, but they end up being infinity, which means we have vertical tangent lines. All right, so that means one of my answers is x equals 0 is one of my answers for, I don't know if it's really x equals 0, it's what? It's theta 0. Okay, yeah, I'm getting my variables mixed up. All right, it's our theta. So at theta equals 0 is one of my answers. So I got to figure out my coordinates. And then the other one is where theta equals 2 pi. I've got another vertical tangent line. So the problem said on the question, what are the points? So I have to go back up here to my parametric equations and plug in the values to get the answers. All right, so the first one is where theta is 0. So sine is 0, 0. Theta is 0. So this is going to give me 0 times r, so x is going to be 0. So I was actually right to begin with, even though the way I was thinking was wrong. All right, and then I want my y coordinate when theta is 0. So theta is 0 over here, so the cosine of 0 is 1. 1 minus 1 is 0. 0 times r means the y value is also 0. So at theta equals 0, we have the point 0, 0, which is where we have a vertical tangent line. Okay? Then I need to do 2 pi. So it's not going to be the same answer, if that's what you're thinking. So we put a 2 pi in here. The sine of 2 pi is 0, but you're putting a 2 pi right here. So that means we're going to have 2 pi times r. So my x coordinate is 2 pi times r. Then I'm putting 2 pi into my y value over here. So 2 pi, the cosine of 2 pi is 1. 1 minus 1 is 0, so my y value is going to be 0. So that answer is 2 pi r, okay, comma 0. And so I have a vertical tangent line there. So the question was, where are the points where we have vertical tangent lines? When I did the test, the original test with my denominator has to be 0, but my numerator can't be 0 to have a vertical tangent line, I ended up, that test kind of failed me. I didn't have any, they canceled each other out. So we have to investigate using the limit of the derivative at those values and do L'Hopital's rule to see what the answers are. And they ended up both being infinity, which means we do indeed have slopes of infinity, which means vertical tangent lines. And so I took those two values, 0 and 2 pi, and I put them into my parametric equations in order to find the x and y coordinate of the points where I have vertical tangent lines. So that's how I got the answers 0, 0, and 2 pi r, 0. Now, to talk just a little bit about what this is. This is a cycloid, and the r is its radius. So this is kind of a generic problem. So you can have a cycloid with different radii. So if this was a 5 here, then down here on my horizontal tangent line, I would put a 5 in here. So that would be at the point 5 pi 10. If r was, say, 3, had a radius of 3 on your cycloid, then these r's would be 3s. So that would be 3 pi comma 6. So the same thing over here on the vertical tangent lines. All right. This r is a radius. It's just a generic equation for a cycloid. And so the r can be any radius. So if my radius was a 5, then I would have a vertical tangent line at 10 pi comma 0. If the r was a 3, that means my vertical tangent line would be at 6 pi comma 0. And then the other one would still be the origin. So these are just a generic equation for a cycloid with any radius r. And so we are still able to manipulate and find the vertical and horizontal tangent lines even with not knowing that radius, okay? So this gives you a general answer for all cycloids. So it has a vertical tangent line at 0, 0, and a vertical tangent line at 2 pi r 0, no matter what the r is. All right, so hopefully that helps you with finding vertical and horizontal tangent lines. Just remember you have to do a limit if you end up with the indeterminate form and both of your top and your bottom are 0. You have to investigate a little further to see whether there's a vertical or tangent line or nothing there at that point. All right, so go do some practice and then I'll answer any questions you have during our Zoom. Oh, let me go tell you what your problems are. They're on the end here too. Plus they're in Canvas. You've got page 651. You're doing 1 to 21 odd plus number 22. I like problem 22. So work on those questions. And again, I will answer any that you have during our Zoom time.